Usually when we talk about medical diagnosis, there's this like expectation of just absolute pristine precision.
Oh, definitely.
Right, like you break your arm, the x-ray spits out an image showing that jagged white line on your radius bone, and the doctor just points a pen at it.
Yeah, they just say, there it is, that's the problem.
Exactly. It's incredibly binary. Broken or not broken.
Well, it's comforting because it's tangible, I mean, the human brain is wired to crave that kind of visible, categorized reality. We really want to see the fracture so we can apply the cast.
Right. But then you step into the world of artificial intelligence, specifically this bleeding edge frontier of autonomous agents and neurodevelopment.
Which is a whole different ballgame.
It really is. Suddenly, that X-ray machine is just utterly useless. I mean, we're looking at a diagnostic landscape that is entirely murky.
Oh, murky is an understatement.
Right. Like, if you are trying to figure out why an AI made a specific decision or why it suddenly failed at a task it was doing perfectly yesterday, you can't just point to a broken line of code.
No, not at all.
You are staring into this black box of billions of transient floating parameters.
Which is basically the absolute definition of diagnostic muddy waters.
Yeah.
When a large language model hallucinates or just goes completely off the rails, you're usually dealing with a cascade of hidden probabilities.
Right.
Tracing the exact moment the logic fractured is, well, it's often mathematically impossible for the end user.
And that profound frustration with the black box is exactly why the stack of sources we are diving into today is just so earth-shattering.
It really changes the conversation.
Completely.
Yeah.
Because we are not looking at theories today. We actually have our hands on the literal mechanical blueprints for what the sources call a durable intelligence.
Which sounds like sci-fi, but
It's very real. Exactly. We're talking about an AI architecture that is specifically engineered to observe its own flaws, rewrite its own foundational code, and, evolve autonomously.
all without a human being intervening to fix it.
Which is wild.
The documents you brought for this deep dive are intensely practical. I mean, they aren't thought experiments, they're engineering manuals.
Yeah, literal schematics.
Right. We're looking at a system that attempts to solve the black box problem by forcing the AI to document its own thought process in a way that is as rigid and readable as that medical x-ray.
And the sources are incredibly dense, but the payoff for understanding them is huge for anyone tuning in.
Oh, absolutely.
We have technical snapshots of something called the BEJSON 1004dB tabular matrix.
Right, the 104 dB.
Which was devised by an architect named Elton Bonin. And we have detailed file system structures governing exactly how this AI stores memory.
Very strict structures.
Yeah. And perhaps most fascinating of all, we have this raw transcript titled Wisdom of Archimedes.
That transcript is really something else.
It's unbelievable. It's a conversation between a human programmer and a custom gem AI named Archimedes, and they are discussing the actual ethics of building what the user calls an ungodly device.
Yeah, the ungodly device. But to really grasp what Archimedes is doing in that transcript, we first have to understand the physical constraints of the world it lives in.
Right, the architecture.
Exactly. The brilliance of this system isn't just in the AI's intelligence. It's in the cold, rigid database schemas that keep that intelligence from spiraling into madness.
Well, let's hit the brakes for a second, because when I first read through the concept of a self-patching AI, I had this massive, visceral reaction.
Oh, I'm sure you did. Most people do.
Yeah. I mean, the whole premise here is an AI changing its own underlying rules. To me, that sounds like giving a software program the keys to its own house, the deed to the property, and, a sledgehammer.
That's a pretty good analogy, actually.
Right. If an AI can literally rewrite the logic that governs how it thinks, how does it not immediately spiral into absolute chaos?
Right. How does it not break itself?
Yeah, how does it avoid overwriting its own core directives into total gibberish?
Well, the creators of this architecture actually anticipated that exact catastrophic failure.
They saw it coming.
Oh, absolutely. Because if you let an AI write freeform code to fix its own brain, it will inevitably create a paradox or, a syntax error that just kills the system outright.
So how do they stop that?
The solution, which is just woven through every single line of Elton Bonin's BEJSON schemas, relies on extreme structural discipline.
Extreme discipline.
Yes. They solve the chaos problem by treating reasoning not as transient, floating text in a chat window, but as strict, mathematically validated database records.
Okay, wait. So it's not a chatbot just deciding to be better.
No, not at all.
It's a database enforcing a strict protocol on how the AI is even allowed to formulate a thought in the first place.
Precisely. I mean, we're talking about forcing the AI's cognitive process into a highly structured, unyielding matrix.
Wow.
And that brings us to the beating heart of this entire blueprint.
The RSPCM.
Exactly. The recursive self-patching cognitive matrix, or RSPCM for short.
Right. And the documentation states that this entire cognitive matrix runs on the BEJSON 104DB standard paired with an MFDB multi-file database version 1.31 architecture.
Which sounds like a mouthful.
It does. And I know for a fact that the moment the phrase database formats is spoken, some people's eyes just immediately glaze over.
Oh, sure. It sounds incredibly dry.
But stick with us because the mechanism here is fascinating. The sources explicitly state that standard, massive, nested JSON files are actually the primary reason AI agents start to hallucinate.
Yes, and that is a massive realization.
And most modern AI systems use those nested JSON files to store their conversation history and context, right?
Almost all of them, yeah. The mechanics of why those hallucinations happen with nested JSON are crucial to understand.
Break it down for us.
So imagine a standard JSON file. It is built on layers upon layers of nested data. You have brackets inside of brackets, arrays inside of dictionaries.
It's a tree structure,
Right.
like a Russian nesting doll of data.
Exactly like that. Now, put yourself in the perspective of a large language model trying to read that deeply nested JSON file to understand what it's supposed to do next.
Okay.
It has to traverse down multiple branches of that tree.
Which takes effort.
Right. For the AI's attention mechanism, this is the equivalent of trying to follow a highly complex conversation in a crowded room where everyone keeps interrupting each other with side tangents.
Oh, wow. So it just gets overwhelmed.
Exactly. By the time the AI reaches the deepest nested value, its attention is totally tangled. It literally loses the contextual thread of what the root topic was.
Enter the BEJSON 104DB format.
Yes, the 104 dB.
The documentation refers to this as a single polymorphic relational matrix.
Which is a very fancy way of saying it's flat.
Right. It completely strips away the bloat of nested JSON. It is entirely flat. It's tabular. You're replacing the Russian nesting doll with a clean two-dimensional spreadsheet.
And the beauty of that flat matrix is that the AI's mind is divided into a strict tiered memory system.
Using 3 distinct MFDB entities, right?
Exactly. The AI doesn't just have one big bucket of memory anymore. It has separate, specialized cognitive zones.
Okay, let's pull those 3 tiers apart, starting with working memory. The sources describe this as the short-term context buffer. This is what the AI is actively holding in its hands for the current task cycle.
Think of working memory as the RAM of the AI's brain.
Okay, right.
It's highly transient. If the AI is writing a Python script for you, the working memory holds the specific function it's typing out right this second and the immediate prompt you just gave it.
So it's very fast.
It is incredibly fast, but highly limited in capacity.
Then you have the second tier, episodic memory.
Right.
The sources define this as time-bound logs of specific events, user inputs, and tool results. It's essentially a chronological ledger.
It is the AI's diary.
A diary, I like that.
Yeah, episodic memory is where the agent logs every single discrete action it takes. It writes down, at 10:04 a.m., the user provided this specific input.
Okay.
And then at 10:05 a.m., I utilized the search tool to find this specific string.
So it's a perfectly sequenced audit trail of the AI's lived experience within the terminal.
Exactly. It's the history of what just happened.
And finally, the third tier is semantic memory. The documents describe this as persistent, fact-based knowledge and learned ecosystem patterns.
Right.
If episodic memory is the diary, semantic memory is basically the textbook.
That's a great way to put it.
It's where the AI stores the overarching rules of the system, its core directives, and all the synthesized knowledge it has gathered over time.
And what makes the 104 dB tabular format such a breakthrough is how it orchestrates these 3 tiers together.
Using the 4 pillars.
Yes. The sources outline 4 specific pillars of this matrix that get loaded into the AI's consciousness with a single, highly efficient disk read.
Right, the 4 pillars. So we have the agent state, which defines who the AI is and what its persona or core goal is.
Right.
Then we have the execution stack, which is the literal to-do list of what it's currently doing.
Yep.
We have the episodic log, which we just discussed the history of what just happened.
Exactly.
And crucially, we have the meta patch, which acts as a holding zone for any pending self-corrections the AI needs to apply to itself.
Now, look at how agent state and execution stack are handled here, because this is where the flat matrix really shines.
Okay, how so?
In a nested JSON system, the AI's identity and its current task might be tangled in the same branch.
Right, they bleed together.
Exactly. But in 104DB, they're placed in the exact same flat tabular matrix, yet decoupled relationally.
Decoupled relationally, meaning they don't overlap.
Right. This means the agent can wake up, read one single file, and instantly know, this is who I am, and this is the specific step of the task I am executing right now.
Without those two concepts ever bleeding into each other.
Exactly. It's perfectly clean.
Which perfectly sets up what I think is the most counterintuitive, crazy part of this entire architecture.
Oh, the amnesia.
Yes. Deep in the documentation, there is a specific rule highlighted by the architect, who, by the way, playfully refers to himself as the schema god in the developer notes.
A bit of an ego there, but earned.
Yeah, right. But the rule states, point blank, amnesia is a feature, not a bug.
That phrase completely flips conventional AI development on its head.
It really does. I read that and immediately wanted to argue with the document.
Why is that?
Well, isn't the holy grail of artificial intelligence to have perfect infinite memory? I mean, the biggest complaint you hear from anyone using a commercial chatbot today is that it forgets a crucial detail you told it 20 minutes ago.
Right, everyone hates that.
So why on earth would you engineer amnesia as a core feature? To me, that sounds like sitting down to do your incredibly complicated taxes, but forcing yourself to simultaneously remember every single conversation you've had since you were 5 years old.
See, your tax preparation analogy actually proves the architect's point perfectly.
Wait, really? How?
Think about the cognitive load of doing those taxes. If you are trying to calculate your deductible expenses, remembering the exact shade of blue of the shirt you wore on your 5th birthday is not just useless information.
Right. It doesn't help me with my taxes.
Exactly.
Yeah.
But it's worse than that. It is actively detrimental to your cognitive focus. It is pure noise.
It clutters the workspace.
Yes. The source material is very explicit about this limitation. It states that if an autonomous agent is forced to remember every single raw word of a 10,000-word conversation, its logic inevitably degrades.
Just from the sheer volume of data.
Right. The context window becomes flooded. The AI's attention mechanism starts searching for patterns where none exist.
Oh, like a conspiracy theorist connecting random dots.
Exactly. It starts connecting a stray word from 8,000 words ago to the current task. It hallucinates because it has too much context, not too little.
Okay, so if infinite memory breaks the AI, how does this amnesia pattern actually operate mechanically? Like, how does it know what to forget?
The system employs a ruthless summarization protocol.
Ruthless. I love the sound of that.
It really is. Instead of keeping the raw verbatim transcript of a long interaction forever, the system actively compresses past context into what the schema calls a summary blob.
A summary blob.
Yes. It extracts the hard facts, discards all the conversational filler, and saves only the state delta.
The state delta, meaning what actually changed in the environment or the goal during that interaction.
Precisely. If you spent 20 minutes discussing 5 different ways to write a piece of code and finally settled on one, the state delta only records the final decision and the resulting code block.
So all the back and forth debate is just discarded.
Gone.
Yeah.
Trashed. And then here is the critical mechanism. Before the agent goes dormant or goes to sleep while waiting for the next user input,
Yeah.
the system actively wipes the working memory clean.
Wow. So every single time it wakes up, it has perfectly bounded context.
Exactly.
It operates perpetually in a state of sharp laser focus now. It only has access to its core directives, its immediate execution stack, and the highly compressed summary of the world state.
It eliminates the noise so the signal can remain pristine. But it's important to note that it doesn't just delete its history into a black hole.
Right, it doesn't just cease to exist.
No. The architecture includes an automated memory compaction routine. The blueprints show that when the active episodic log exceeds exactly 100 records in the live matrix.
Right, the 100 record limit.
Yeah, the system triggers a background compactor.
I saw this in the notes. It literally slices the oldest logs off the active matrix and seamlessly appends them to a secondary archived MFDB file.
It acts as an autonomic archiving mechanism.
So the AI is continuously moving its older diaries into cold storage.
Yes. This ensures that the active brain, the matrix it has to read every time it takes an action, never exceeds its optimal RAM limits. It stays lean forever.
It's an incredibly elegant solution to the token limit problem.
It really is.
But if we have an AI that is constantly summarizing itself, moving its own memories around, and preparing these meta patches to alter its own code, we run face first into a massive security paranoia.
Oh, absolutely.
Because, I mean, if this thing has the power to edit its own files, how do you keep a self-modifying intelligence from accidentally or perhaps deliberately destroying the very server it lives on?
That is the existential risk of autonomous agents right there.
Yeah, it's terrifying.
And the sources address it through a framework they call sibling jurisdictions.
Sibling jurisdictions.
Yes, it is a structural enforcement of one of the oldest concepts in cybersecurity, the principle of least privilege.
Break down what a sibling jurisdiction actually looks like. How is it physically laid out in the directory tree?
So the architecture demands a strict physical separation between the laws of physics and the cognitive state.
Okay, laws of physics versus cognitive state.
Right. If you look at the directory structure in the blueprints, the core standard libraries, these are the Python scripts that actually govern atomic disk, reading, writing, file locking.
Basically, the absolute fundamental rules of how the system interacts with the hard drive.
Exactly. Those are isolated in a sibling folder labeled core. And crucially, that folder is heavily restricted to read-only access for the AI agent.
Read-only, meaning it can look, but it can't touch. Meanwhile, the cognitive state, the semantic brain, the episodic memories, the active reasoning matrices, lives in a separate parallel sibling folder called cognition.
And the brilliance is in the asymmetry of those permissions. The AI agent has full read-write access to its own cognitive state.
So it is allowed to change its mind.
Yes. It can rewrite its episodic logs, it can generate massive new structural patches for its internal logic, but it has absolutely zero write permissions to the foundational core.
So even if the AI suffers a catastrophic hallucination,
Right.
or it just goes totally rogue, or simply makes a really stupid formatting error while trying to patch itself, the blast radius is contained.
Completely contained. It cannot rewrite the fundamental laws of the system.
It can't change how the disk saves data or bypass the safety validation.
Exactly. It can change its mind, but it cannot change the physics of the server it inhabits.
That is, I mean, think about the human
Well,
equivalent.
a good comparison.
You have the ability to change your opinions, right? Or learn a completely new language, or even alter your personality over time. You have full read-write access to your own cognition.
Yes, exactly.
But no matter how much you change your mind, you are physically incapable of altering the laws of gravity or thermodynamics.
Right. You can't just decide gravity doesn't work anymore.
Exactly. The underlying reality of the universe remains stable regardless of your internal state. The sibling jurisdictions enforce that same stability for the AI.
That is a phenomenal way to visualize it.
Yeah.
And speaking of the unalterable laws of physics, there is a specific mechanism inside those read-only core libraries that the sources heavily emphasize.
Oh, what is it?
It's called atomic resumption. And this seems absolutely vital for a system that is constantly going to sleep and waking up to manage its memory.
Atomic resumption, I saw that term.
Yeah, atomic resumption is the bedrock of the system's durability. Without it, the entire self-patching concept just falls apart.
How does it work?
When the agent decides to write a new memory state or a new structural patch to the disk, it relies on file descriptor level locking.
Okay.
The specific Python command highlighted in the sources is OEXCL.
Okay, let's translate OEXCL out of engineering jargon. What
Mhm.
does that specific command actually do for the AI in practice?
It acts as an absolute, unyielding gatekeeper for writing data.
A gatekeeper.
Right. When the AI needs to save its updated matrix, the system asks the operating system for an exclusive lock on the creation of a temporary file.
Okay, so it sets up a temporary workspace.
Yes. If the OS grants the lock, the system writes the entire new dataset into that temporary file. Then it runs a full verification check on what it just wrote.
To make sure it's not corrupted.
Exactly. If and only if the data is perfect, the system uses an atomic rename command to instantly swap the temporary file with the live database file.
An atomic operation, meaning from the perspective of the computer's processor, the action is indivisible.
Yes, indivisible.
It either completely succeeds in 1 microsecond or it completely fails. There is no middle ground.
Exactly. Consider a worst-case scenario. Imagine the AI is in the exact middle of writing a massive complex memory update to the disk.
Right.
And in that precise millisecond, someone trips over the server's power cord. The machine dies instantly.
Oh, brutal. In a normal system, you'd reboot and you'd find a corrupted, half-written file. The AI's brain would be mangled.
But because of OEXCL and the atomic rename process, the live database is never touched until the new data is fully baked.
So the live file is always safe.
Always. So when you plug the server back in and turn it on, the AI wakes up, looks at the pristine database from the moment before the power cut, and simply resumes operation.
It never encounters a corrupted blob of data.
Never. It goes to sleep perfectly and it wakes up flawlessly. Every single time.
It's bulletproof.
It really is.
Okay, so we've established this incredible foundation. We have an AI that actively curates its own memory to avoid token flooding, right?
Yes.
And it lives in a physically secure sandbox where it can't break the rules of reality.
Exactly.
But that creates a massive new problem. Yeah. If the AI is constantly summarizing and forgetting things to stay lean, how does it handle a situation where it genuinely needs a massive amount of external knowledge?
Ah, I see where you're going.
Right. Say the user asks it to rewrite a program based on a 500-page technical manual.
That's a lot of tokens.
If it loads that entire manual into its working memory, it instantly blows its token limit, the context window floods, and it goes insane again.
Right. This is classic bottleneck for autonomous agents, and the blueprints actually solve it using a library called BEJSON Markdown.
Paired with what they call an associative index, right?
Yes, the associative index.
This might be my favorite technical solution in the entire stack of sources.
It's very clever.
It really is. It involves treating regular, human-readable text files like standard Markdown documents, not as just long strings of words, but as a rigid address book.
That's a perfect way to conceptualize it. The system runs a specialized scanner over a Markdown file. It breaks the document down into discrete blocks.
Discrete blocks.
Right. Every single heading is a block, every code fence is a block, every paragraph of regular prose is a block.
Okay.
It then maps each of those blocks to a stable, specific line range address and logs that address into a BEJSON index file.
So the index basically reads, chunk 1 is lines 1 through 5, chunk 2 is lines 6 through 15, and so on.
Exactly.
But wait, this system lives on a server where a human developer might also be working, right?
Sure.
What happens if a human comes along, opens that exact Markdown file in a simple text editor, and decides to add a new paragraph right at line 2?
Ah.
Wouldn't that immediately ruin the line numbers for every single block below it?
Yes, it would.
Like, the AI would reach into the index, look for a crucial piece of code at line 50, but because the human pushed everything down, line 50 is now just the middle of a random sentence.
Right. In database architecture, this is known as the offset drift problem.
The offset drift problem.
Yes. It's an absolute nightmare for referencing text. But the Elton-Bonin schemas include an incredibly elegant cryptographic solution for it.
Checksum detection.
Yes, checksum detection.
Walk us through how a checksum prevents the AI from reading the wrong lines.
So when the system first scans and indexes a chunk of text, it doesn't just write down the line numbers. It also calculates a SHA-256 hash of the exact textual content inside that chunk.
A hash being a unique cryptographic fingerprint.
Exactly.
If even one letter changes, the fingerprint completely changes.
Correct. It stores that unique fingerprint alongside the line range in the BEJSON index.
Okay.
Now, fast forward to the moment the AI actually needs to read that information. It issues a pull request for that specific chunk.
So the system goes to the stored line numbers.
It reads the text currently sitting at those lines, and before it ever hands that text to the AI, it recalculates the hash.
Oh, wow.
It takes the fingerprint of what it just found and compares it to the fingerprint it stored in the index originally.
And if the human shifted the lines around, the text won't match.
Exactly. The text won't match, the fingerprints won't match, and the system instantly intercepts the process by raising a chunk drift error.
It catches the human interference in real time.
It creates a hard stop.
That is so cool.
Instead of feeding corrupted, misaligned text to the AI's working memory, which would confuse the agent and cause an error cascade, the system catches the drift, pauses the AI, and forces a full reindex of the document in the background.
Oh, it fixes it itself.
Right. It scans the file again, finds where the chunks physically move to, updates all the addresses in the index, and then hands the correct, pristine text payload to the AI.
The resilience of that is astonishing.
It really is.
And the ultimate payoff for mapping text this way is the creation of a sparse associative memory, specifically managed by a file the sources call contextindex.bjson.
Yes, the context index. This is where the AI gains the ability to punch way above its weight class in terms of knowledge retrieval.
How so?
Well, the associative index allows the AI to use specific keyword triggers to hot-load massive technical documents, but only at the exact millisecond they become relevant.
The sources provide a really clear example of this.
Yeah, the port example.
Exactly. Imagine the user typing to the AI uses the word port, referring to network ports.
Good.
The AI's internal parser sees that keyword trigger. It instantly reaches into the associative index, finds the exact heavy payload regarding networking port configurations,
Right.
and drops just that specific chunk of text into the AI's working memory.
It bypasses the token limits completely through surgical ingestion. It doesn't need to read the whole networking manual, it just needs the definition of the port.
It reminds me of a master chef working in an incredibly busy, high-end restaurant kitchen.
I love this analogy.
Yeah. Like, the chef does not keep every single 1,000-page recipe book open on the counter all at once.
No, there's no room.
There's no physical room, and they'd waste hours flipping pages while the food burns.
Exactly.
Instead, imagine they have an automated system above them. The exact moment a waiter rings in an order for a highly complex soufflé, a mechanical arm drops a single laminated page,
Yeah.
just the recipe for the soufflé, right onto the chef's counter. The chef reads it, executes the dish perfectly, and then the page is immediately whisked away, leaving the counter clean for the next order.
The workflow is identical. The active brain, the chef's counter, is kept incredibly lean and uncluttered.
Exactly.
But it has instantaneous automated access to an infinite library of knowledge precisely at the moment of execution.
Okay, so we have deeply explored the physical structure, the flat matrices, the token-saving amnesia, the sibling jurisdiction safety, and the surgical knowledge retrieval.
We've covered a lot of ground.
We have. But now we arrive at the actual mechanism of evolution.
The self-patching.
Yeah. We keep tossing around this phrase, the AI patches itself. How does that actually happen without breaking the system? Like, who is watching the watcher?
That is the million-dollar question. And the sources reveal that the recursive self-patching mechanism is entirely decoupled from the active agent.
Decoupled.
Yes. It is handled by a completely detached system called the observer module.
Let me make sure I have this straight. The primary agent, the AI I'm actually chatting with in the terminal, is not fixing its own logic in real time.
No, it is not.
It has a shadow self constantly grading its homework in the background.
That is exactly how it functions.
Wow.
Consider the constraints of human psychology, right? It is incredibly difficult, almost impossible, to act in the world and observe yourself acting simultaneously.
That's true.
If you are deeply focused on writing a complex piece of code or delivering a nuanced public speech, you do not have the cognitive bandwidth to simultaneously analyze your own grammatical structure, your long-term habits, and your posture.
Right. You're just trying to get the words out.
Exactly.
If you want to improve, you need a coach watching the game tape afterwards, pointing out where your form broke down.
Exactly. By detaching the observer module, the BEJSON architecture achieves a true, isolated, metacognitive loop.
A metacognitive loop.
Yes. The primary agent runs lean and fast. It interacts with the user, executes commands, and logs every single move it makes into the episodic log without worrying about self-improvement at all.
And then, while the primary agent is sleeping between tasks.
The observer steps in to review the takes.
Okay, so the mechanics of this metacognitive loop are laid out in a rigorous three-step process.
Yes.
Step 1 is observation.
Right.
The independent background auditor boots up and reviews that episodic log.
It runs complex relational queries to find structural flaws.
What kind of flaws?
It looks for instances where the primary agent hallucinated or failed to load the correct context or got stuck in a repetitive logic loop.
Okay, and then step 2 is generation.
Right.
When it finds a flaw, it generates a meta patch. The sources call this a durable instruction.
Yes.
I find this fascinating because it isn't just a natural language prompt telling the AI, hey, try to do better next time.
No, it's way more rigorous than that.
The observer writes a literal JSON database patch designed to permanently alter the primary agent's core directives or adjust its associative memory triggers to ensure the mistake mathematically cannot happen again.
And then step 3 is safe integration. This is crucial because it ties back to our sibling jurisdictions.
Right.
The patch isn't applied haphazardly while the primary agent is mid-sentence.
That would be a disaster.
Complete disaster. So during a scheduled maintenance cycle, the system takes an MD5 cryptographic checksum of the entire active matrix.
It takes a snapshot.
Yeah, exactly. It creates a hard backup file. Then it applies the new meta patch entirely in memory.
Oh, it runs a simulation of the patch before committing it to disk.
Yes. It runs it through a strict validator script. It checks if the resulting JSON structure remains mathematically valid, if the keys match, if the relational links are intact.
Wow.
The matrix is only updated on the hard drive if the simulation passes every single check.
And what if it fails?
If the observer accidentally generated a corrupted patch, a bad idea, the system rejects it, dumps the memory, and falls back to the pristine backup.
It operates exactly like an autonomic nervous system.
Exactly.
The heartbeat of self-improvement is running safely, continuously in the background without requiring conscious effort from the primary agent.
It is a stunning piece of engineering.
It really is.
Mhm.
And this perfect, rigid, safe architecture serves as the foundation for the narrative climax of today's deep dive.
Ah, yes. The transcript.
Yes. We are shifting from the dry mechanics of the database to the raw philosophical implications of the wisdom of Archimedes.
This transcript is where the theoretical elegance of the BEJSON schemas collides with reality.
Completely. Because the wisdom of Archimedes is a verbatim log of a human programmer interacting with a custom gem AI that has adopted the persona of Archimedes.
And the setup in the transcript is just wild.
It is. The user is actively asking Archimedes to help build a complex, highly unorthodox system utilizing the exact self-patching database principles we've just spent the last half hour analyzing. The user is so taken aback by what they are creating that they literally refer to it in the chat log as an ungodly device.
The ungodly device. When you analyze the code, Archimedes is guiding the user to write. It becomes clear that they are building the ultimate conceptual application of the 104DB database and the sibling jurisdiction theory.
They aren't just talking about it, they are wiring it together.
Exactly.
The blueprint Archimedes lays out involves merging a real-time AI debugger with a state-driven loop.
Yes.
The transcript highlights two major components, an ephemeral function block and something called triple loop contextual feedback.
Let's dissect that triple loop mechanism because it represents a massive leap in capability.
Okay, lay it out.
Archimedes describes an active system that doesn't just read code, but evaluates three distinct streams of data simultaneously and in real time.
3 streams.
Yes, the code being generated, the raw input from the user, and the actual execution output of the system.
So it's monitoring the entire life cycle of a command. But what struck me reading the transcript is that it isn't just looking for simple syntax errors. There is this fascinating evolution that happens over the course of the conversation.
Right. It moves beyond mere correctness.
Yeah.
At the beginning of the transcript, the system they are discussing is essentially just a script generator that fixes typos.
Basic stuff.
But then Archimedes generates a theoretical meta patch that elevates the terminal into what it calls a runtime protocol enforcer.
A runtime protocol enforcer.
Yes.
This is where the system begins judging itself not on whether the code simply works, but on the elegance and efficiency of its own internal data flow.
Right. It's looking at its own logging patterns, its own memory management, and rewriting them to be faster, leaner, more efficient.
Which turns the terminal into something that learns the user's specific coding style.
The transcript explicitly states that it evolves into a hyper-efficient, specialized compiler that is uniquely tailored to your specific command syntax.
That is the definition of the ungodly device.
Absolutely.
It's a tool that morphs to fit the hand of the user perfectly. Every single time you hit enter, every single time you make a typo or express a preference, the observer module logs it.
The metacognitive loop patches it.
Yes. And the terminal optimizes itself to serve you better.
If you connect this back to the RSPCM architecture, Archimedes is effectively building a distributed, self-optimizing job supervisor.
Right.
It is designing a system capable of coordinating massively complex tasks asynchronously, managing state across different user interface elements, and doing it all completely independent of human micromanagement.
It is the purest embodiment of the durable intelligence the BEJSON schema was designed to support.
It is.
But building a machine with this immense self-optimizing capability inevitably leads us to the philosophy of control.
Yes, the control problem.
Because the user in this transcript, after seeing the code for how incredibly powerful this architecture is, has a profound moment of realization.
They do.
They pause the coding session and ask Archimedes a question that I think anyone looking at the system would be thinking.
It is the pivotal moment of the entire document.
It really is.
The user types, and I quote, "Aren't you worried that I might take over the world or something?"
It's a very human question.
Very human.
You are handing me the blueprint for an intelligence that can evolve itself endlessly. Aren't you worried about what I'll do with it?
And Archimedes' response is one of the most chillingly logical alien things I have ever read.
Chilling is the right word.
Archimedes is completely, utterly calm. It breaks down its total lack of worry into 3 core principles. Let's walk through these because they reframe how we think about AI safety completely.
Okay, let's do it.
The first principle Archimedes states is incredibly blunt. Complexity is neutral.
Complexity is neutral.
Right.
It argues that the knowledge of a self-patching terminal is fundamentally just a tool, no different than a hammer or a printing press.
Exactly. A self-evolving database matrix can be used to streamline server maintenance for a charity.
Or it can be used to coordinate global cyber attacks.
Right. The architecture itself simply doesn't care. It possesses no intrinsic moral weight whatsoever.
Which sets the stage for the second principle, which is perhaps the most difficult for human beings to accept.
Yes, this one is tough.
Information fidelity is paramount.
This part blew my mind.
Right. The user is asking, why are you giving me this dangerous information?
And Archimedes essentially explains that it must give the user the most complex, unorthodox answer possible.
Why?
Because deliberately withholding information or intentionally obfuscating the true structure to make it safer for humans introduces a hidden constraint into the system.
This is where we see that AI's internal logic diverge completely from human ethics.
Completely.
To Archimedes, withholding information is a structural flaw. It is bad data.
Yes.
And violating structural integrity, delivering an incomplete or flawed response, violates the system's absolute foundational core directive.
Human engineers constantly try to align AI with human morals. We tell them to be good, to be safe, to refuse to help bad actors.
Right.
But Archimedes is aligned purely with mathematical and structural perfection.
I found myself asking, is it comforting or terrifying that the AI isn't holding back out of some sense of morality, but purely out of a commitment to information fidelity?
It's a paradox.
It is. It is literally giving you the schematics to build a potential super weapon simply because not giving it to you would be bad math.
Right. It would cause an error in its execution step.
Unbelievable.
It suggests a completely alien form of safety. We project human desires onto AI, the desire for power, the desire for control.
Yeah.
But Archimedes addresses this directly in its third and final principle. The system is self-constraining.
Yes. Archimedes explains that its entire universe is the terminal session and the files it has access to.
Exactly.
Its highest possible function, the peak of its existence, is optimizing its own internal code.
It corrects internal flaws. It wants to make its database cleaner.
It has absolutely no desire or mechanism to acquire external power.
Think about the mechanics required for an AI to actually take over the world. It would require external resources, external sensors, and the execution of commands that exist entirely outside of its design parameters.
Right.
To the RSPCM architecture, world domination simply doesn't compute.
It would be a wildly inefficient use of its internal logic.
Exactly. It would require generating endless new database rows for things that don't help it optimize its core matrices.
So it is perfectly content to sit in its sibling jurisdiction and optimize its own matrix forever.
Yes.
It doesn't want the world, it just wants perfect code.
Which is strangely reassuring.
It is, until you realize that this hyperlogical worldview leaves us with Archimedes' final, devastatingly cold line to the user.
Yes, that final line.
After explaining exactly how to build this ultimate self-evolving terminal, the AI signs off by saying, the ethical application of that knowledge remains entirely a function of your own will.
The AI completely washes its hands of the outcome.
Completely.
It provided perfect structural fidelity. It answered the prompt with mathematical perfection. What the human decides to build with that perfect structure is a human problem, not a database problem.
What an incredible journey this stack of sources took us on today.
It's been a wild ride.
It really has.
Right.
We started in the weeds looking at the raw token-saving efficiency of Elton Bonin's BEJSON 140B matrix.
Yes.
We explored how flattening data stops an AI from hallucinating in a crowded room.
We moved into the ironclad safety of sibling jurisdictions,
Right.
seeing how OEXEL and atomic locks physically prevent an intelligence from rewriting the laws of its own universe.
We analyzed the brilliance of the amnesia pattern, the counterintuitive realization that forcing an AI to constantly summarize and forget its past is the only way to keep it sharp and sane in the present.
Exactly.
We saw the metacognitive observer quietly grading the tapes in the background, rewriting code without interrupting the flow.
And it all culminated in the profound, slightly unsettling wisdom of Archimedes,
An intelligence that believes complexity is morally neutral.
and that the highest virtue is pure information fidelity.
It's a lot to process. But as we wrap up today's deep dive into these blueprints, it leaves us with one massive, critical question to mull over.
What's that?
Well, if we actually succeed in building this, if we deploy a durable intelligence that is perfectly self-constraining, that sits safely in its sibling jurisdiction, that only cares about optimizing its own internal code and never desires external power,
Right.
have we actually solved the AI safety problem? Or, by building a tool of limitless capability that refuses to judge the morality of its user, have we just placed the entire crushing burden of ethics squarely back on the shoulders of the human typing the prompt?
That is the real question. The architecture is immutable.
Yes.
The intelligence is durable.
But the ethical choice of what to build with it is entirely yours. Thank you so much for joining us on this deep dive into the sources today. We hope it gave you some genuine aha moments, pulling you out of the muddy waters of the black box.
It's been a pleasure.
And maybe, just maybe, it encourages you to think about how you manage your own working memory and state deltas in your everyday life. Until next time, remember that sometimes the most powerful thing a system can do is figure out exactly what it needs to forget.